Can you guys see my screen?
Yes.
Okay. We have 1, 2, 3. Let's just wait for one more person, then we start. Can anybody tell me how? Yeah. So before we even, yeah, exactly, the assignments. So let's start with you. Who do I start with now? Can you? Oh, my intelligence. Okay. Who do I start with? So let's start with Buluwatife. Where is your assignment? Buluwatife, can you hear me? Are you in this meeting? Let's jump to Zainab, since Buluwatife says he has issue with our network. So Zainab, assignments.
Actually, I didn't understand how to write the code. So when I just copied what the YouTuber was doing, there were errors. And since I didn't even know what I was doing to start with, I didn't know how to fix the errors.
Okay, all right, that's understandable. Emmanuel, your assignment.
I actually missed the last class due to some unforeseen circumstances, so that's why I didn't do the assignment.
Okay. Even though but just make sure, like, did you watch the videos at all? It's still a must, even though you didn't like come to class, because of like recording is being dropped, and also I also dropped some resources also there. So yeah. Okay, let's just start with the three of you for now. But what's if I can't hear you? I want to assume your mic is bad, but then we can start. So welcome guys to another and since this is a recording, right? I've still recording after, right? Okay, cool. So welcome to the class on week 4. So we have, this is more like an introduction crash course to Git development, and I'm teaching you the nooks and crannies and all the nooks and crannies and all like introduction, getting you inspired to love game dev and how you can start making your games as quickly as possible. So in our first week, we did an FPS shooter, and we also sorry, in 1 minute. Okay, so last week we did an FPS shooter, and we also worked on. We talked about how to get introduced to Unity. The other week, talked about C# and how to get involved into scripting with what's it called? With programming, programming C#. So to learn about your loops, your variables, your functions, methods, strings, and all those programming concepts. And you guys built a spaceship. And on week 3, we did psychology of fun, how to make games fun. We talked about particle effects, sound effects, and I give hands-on examples and stuff like that. But today, if you can see my screen clearly, we are going to be talking about physics. So this class must be interactive between the three of you. Oh my God, I turned it off. Can you guys still see my screen? Can you see my screen?
Yeah, I can.
Okay, yeah. So yeah, so who likes physics here? Who has who likes physics? Who basically that's it. So who doesn't like physics? That's probably a better question. So between Zainab and Boluwatife and Emmanuel. Did you like physics? Are you interested in physics at all? In the slightest? Anyone? Okay, so basically, we have to deal with physics in game development, and physics is a key part of game dev. So it depends if you're making a physics-based game. You probably have to add a couple of things to your games, and it's really, really important. So we won't be doing much math or much physics, like more calculation. This is more like a concept, and all those things you learned in secondary school, and let's say year one engineering, or basically we do physics at all. We will get to understand those concepts. So you don't need to have like a having the knowledge is good, but it's not really necessary. Also, these are really basic stuff. Okay, so today we're talking about rigid body, how rigid body works. Talking about 2D and 3D physics, and what to do scripting, manipulating and scripting rigid body physics. I'm going to talk about prototyping today. Okay. So the first, okay, I'm not on this. So the first one, talk about rigid body, and we will get hands-on into. So whenever I'm working on something, I get hands-on into scripting. I hands-on into Unity. So I'm going to just share my screen, my Unity page right now. Can you guys see my screen?
Yeah, I can see it.
Okay, 1 minute. 1 minute. Okay, cool. All right, so rigid body physics. So we're going to talk about rigid body. What is a rigid body? So a rigid body are components that allow the game objects or who. Okay, quick question. What is a game object? We did this in the first class. Anyone? Game objects? Nobody? Communicate are falling my head now.
Game object is everything in your game world, including player character, etc.
All right, that's very brilliant. Who said that? Emmanuel. Okay, cool. So that was very nice. Yeah, so you got it correctly. Game object is basically are your objects in your scene. They are basically the objects in the game world, currently surviving in your game world. So rigid body is a component that allows our game objects to react to real-time physics. This includes things like reaction to forces, gravity, mass, drag, and momentum. So all your basic physics terms, rigid body allows us to apply that, and we'll get to that in motion. Without even adding any code, a rigid body will be pulled to downward by gravity and react to collisions by incoming objects if the right collider component is present. So this is what a rigid body looks like, and we will get to see how that looks like in game. So let me switch on to my Unity. Okay, can you see my screen? Oh yeah, you guys can see my screen, right? Yeah. So the first thing you notice here is that this is this is like a normal basic scene from your from the FPS project we did. I'm going to add physics object to this. I'm going to talk about how physics applies to these different things, right? So the first thing I want to do, I want to create a new ball. I want to create a ball basically, right? And I'll press plus sign and a sphere, right? So a sphere has it's basically like a spherical shape. I could place it around here. So this is our player character here. And I could place it anywhere I want to place it actually in the world. So currently our ball has a really pastel looking. Let's just change the material real quick. Something like let's say blue, I guess. Okay, so basic blue. So we have a blue ball right now. And you can see in the inspector view currently, we have the mesh render, which is like what displays the ball on the screen, the mesh filter, and we have a default by default. We have the mesh collider. So the collider basically, the sphere collider, sorry. So the sphere collider is basically what you use to like collide with the sphere at a goal. But we don't really need that right now. What you want to add is a rigid body. So how can you add a rigid body? There are two ways. You can come here to physics and go to rigid body. So added a rigid body. Or I can just come to add components and write rigid body on the top bar here, and I get my rigid body. Awesome. All right. So, but then let's see what it looks like without a collider or without a rigid body component added to it. So once I press play, okay, so once I press play, you guys will see. So I can pass through the 1 minute. Okay. Samuel, can you please help me to admit anyone who wants to join the meeting? Thank you. So yeah, basically this ball right now is basically uninteresting. I can pass through it. If I shoot it, nothing really happens. So let's now add.
Please excuse
me. Yeah.
The screen is not like it's just stagnant. Nothing is, only one particular thing is showing. I'm not seeing any other thing apart from that particular, like, not, it gets.
Okay, so it's just stagnant, right? It might be a connection, but then I would stop I will stop sharing and share again.
Actually, it's working for me, so I think it's his connection.
Okay, can you see my screen? Just make sure of that.
Yes, I can see it now. Thank you.
Can you see anything? Can you see any movements on the screen right now?
Yes, I can see. Thank you.
Okay. So we just touch. So just to give a recap of it. So this is a normal basic sphere, a game object that doesn't have anything in it. So we can just go around this. It doesn't even do anything. If I shoot it, nothing really happens. So it's useless right now. We can't retire. We can't do anything with it. So let's add a rigid body to this, right? And I probably want to increase the position just a little bit. So let's just focus on the ball as I click on play. So 1 minute. So I focus on the ball. I add a rigid body to it, and the ball fell through the sky. It fell through the ground. Let's just do that one more time so you can get to see. I'll put it higher so you can see it. and you would see what happens. It just falls. So so we can see that what happened is that once you add the rigid body to it, gravity is being applied to the object and it's pulling it down. So gravity is applied to this game object and it's pulling it down and it goes down to infinity, like I say. So the game world is very large, it's literally infinity. So it just keeps going down, and because there's no collision attached to it, that's why it keeps going down. So they want to add collision, want to say, okay, this game object, we want it to have physics, and we also want to like make it collide with the world around it. So we add the components and we add a sphere collider. Because it's a sphere, we add a sphere collider. And how do we know? So we can see here, see how this sphere collider is. There are many other things you can tweak in the sphere collider, but we'll get to that later. So let's click on play. Sorry, give me a minute. I want to drink water. So as you can see, our game object currently is colliding with the ground, and I can hit it. I can't pass through it. It's a full solid object, and I can shoot it. And you can see that once it's being hit, you can see that particle effect showing on top of it. I mean, it's a real object in our scene currently. So we'll talk about a few things about this board right now. Right now, it's not interesting as I hope it to be. So let's do a few things. Number one is we want to make it movable. So let's change the name to a ball. And so the first thing we'll do is the mass. So go to the Rigidbody here. And we go to the mass of the object. So the mass of the object is basically how strong or how heavy this object right now, right? And our mass, the mass of our object currently is on 1, right? So it has a mass of 1 unit. So there's no real units. So there's no real what's it called? Dimension. We just use units here. It's not like Newton or kg. It's just 1 unit. So let's go to our player, and our player has a mass. Sorry, player's mass. Very deep. Minutes. Where did you click that? Oh, okay. Okay. One question. Okay. So let's just reduce this mass to 0.1 quickly. And let's see how it behaves. Okay. So a very big reason why it's still behaving the same way it is for 2 main reasons. Number one is our player controller is not being, it does not have a rigid body on it also. So that way, like Unity cannot calculate the physical interaction between both of them. But right now I would give you guys a very quick cheat to doing physical interactions. So let's have 2 balls. We have ball A. So this ball is this is our first ball, and we have another ball. So I'll just quickly duplicate this, right? So let's make this other ball smaller. So reduce the scale. So take the scale a bit, and it's a bit smaller, and let's change the color. Let's make it red. Right. So we have 2 balls. We have the red ball, and we have the red ball and we have the blue ball, right? So, and they both have a rigid body collision effects. Ball A or ball blue, let me call it ball blue here. So ball blue has a mass of, let's put it to 0.2, and ball red has a mass of, let me change this quickly. Red has a mass of 0.1, right? So that means like ball 2 is definitely stronger than ball 1. So so one thing you should know is that the ball blue, I want to add a force to it. So I'll add a constant force to it, right? So because the force is basically this component adds a force to it in the direction. And right now I want to move it in the in the Z direction. So you can see on this top bar up here, you can see it going Z, right? So we want to move it like this diagonal. So this is how this is Z. I want it to collide with this one. So we want this ball to collide with this one. So this is your Y and this is your X currently. So basically using these things on here, right? So let's add a force to it on the Z-axis, a force of 5. No, a force of actually -5. And why are we going -5? So we can see, if we can check here on our transform. So follow me. If we can check here on our transform, we can see that Z is currently -5, right? So if I move this forward, oh, it's actually going. Oh, okay, that was my mistake. Actually, that's 5. So we want to go in a positive direction. So this is here in the positive direction. I need to collide with this guy, right? And if we are going the opposite way, we are going in the opposite direction. So we want to minus, negatively minus. So one other thing. So let's test this out in play mode. So click on play, and let's see how it looks. So as you can see, oh, that was fast. That was actually fast. 1 minute. So let's put it to 1, a force of 1. So I can see the blue ball is pushing the red ball away, right? And because like it has a constant force being applied to it. So just going to just make sure we can see that clearly on a high note. So I'm just going to separate my do this quickly. Separate my scene. Just going to do this. So to bring this bad boy down here, so you can see the two of them at the same time. Okay. All right, good. So let's do this. Right, so let's click on play. So you can see what's going up here, and I see what's going here down here. So you can see it's pushing it away, and two main reasons. So you can see it keeps going on in the Z direction currently, no matter how much direction changes. So let's now do some experiments. Let's put the blue ball and let's set it to the mass of 0.1, and let's set the red ball to the mass of, let's say, 0.5. So even though the blue ball is bigger in scale, but it has a smaller mass. So let's see what happens. So you can see that it's still pretty hard for you to push it compared to the what's it called? Compared to the other one, right? So basically, the hope. So if you know your physics calculation where F is equals to ma, you can get that the force being applied over time will definitely like push this ball. So if I set the red ball to, let's say, something like 10 now, and I press play, in theory, the blue ball should not be able to move the red ball. So yeah, so it wouldn't move the red ball because of oh, it's actually moving it a little bit because of how the exponential difference in the masses. So it is moving it. So that is one way for us to like play with masses. So another thing is what happens if we also add a force to the red ball, and so add a force to the red ball, and let's give it -5. Right? So, -1, not 5, -1. And they are both of the same mass. So let's say they both have a mass of 1 and 1. What do you think is the expected? And let's make the red ball really small, actually. So, what would be the expected outcome between two of them hitting themselves? So you're going for it, and it's more of a standstill. So basically, in Unity, you can test out different physics simulations and different physics practices. So basically, all what you learned from secondary school or elementary school, you can actually test all them out and see how they interact and behave in the physics world. So we talk about gravity, that gravity is being applied or pulled to these different guys right now. We want to talk about different things in the rigid body. So number one, we have the drag. So the drag is the force. Drag is more like the force stopping it from moving forward or moving in the same direction, which is probably complex stuff, but it's not really needed. So in our rigid body here, as you can see, we have used gravity. Do you want to apply gravity to these objects? So a very cool experiment I do a lot is let's put this red ball. Yeah, put it up a little bit so it's a bit above the ground, and let's move it a little bit forward, and let's turn off. Let's turn off. Let me quick do my lights. Okay, good. I just want to set the lights in. All right, cool. So we have. So okay, both of the balls are actually way above the ground. So just bring this up a little bit and bring this one down. So I'm going to just remove the constant force here. I want to turn off the gravity on the blue ball. I know what. Let's for better experiments. Let's add more red balls around. Let's add more here, one more here, and one more here, and one more here. And let's add a higher force on our blue ball. So let's say it has a force is coming in with a force of 2 units and a mass of 2. So that is bigger than the red balls. All right, and I could set the red balls to have a mass of 0.5. So let's test this out and let's see what happens when an object in gravity hits another object that is currently not in gravity. So forces is already been applied to it. So you can see the balls keep moving up on its own. Kind of act like a balloon actually. I can play around with these ones. Play around with these ones. Okay. So yeah, this is how it behaves. I think maybe make a few adjustments to it, so don't make them collide each other. A few adjustments. So we can test out okay, we're hitting balls without gravity, setting the mass to 0.1, and the ball is this blue ball is coming in a force of 5. So let's test that out. Let's see what happens. Oh, I made a mistake. Sorry, 1 minute. Okay, let's test it out quickly. So yeah, you can definitely see how each of these physics objects actually interact with each other and how they're able to mess around. So let me quickly have an experiment here. So if I click on this blue ball right here, I can like drag it and mess around with it, mess around with balls, and let them keep going. So yeah, so we can definitely like simulate like movements in space or movements on Earth real easily if we want to. So yeah, that is physics for you in 3D. There's way more nuances, but this is the basic things you can do. So you want to see other things you can do, just go to add components here, go to physics. We have box colliders, capsule colliders, character colliders, clothes simulation, configuration joints, constant force, fixed joints, hinge joints, mesh, and any other one, terrain collider, wheel collider. So these are basically physics things you can do. So let's go to the next our next chapter or topic. Okay. So anyone have any question before we move next? Did you guys understand that? Did everyone understand this? Please give me. I need some feedback from you guys. So let me know.
I want to ask a question.
Okay, yeah. Ask the question.
So the ball that was not reacting to gravity, you didn't put a rigid body on it, or what?
No, I just turned off gravity.
Oh, okay, I see. But does it have the same effect
Gravity.
if you don't put a rigid body on it?
No, it doesn't have the same effect.
Thank you.
So you can't. You're not able to interact with it. Yeah. Any other person? All right. Okay. Cool. So the next thing is 2D versus 3D. So we talked about 2D and 3D in our previous sorry. Okay. Talk about 2D and 3D in our previous this thing. In our first class, we all know what 3D is. So 3D is a 3-dimension, and 2D is the 2-dimension, right? So basically, we want to know that there's a big difference when dealing with 2D graphics, 2D physics, and 2D physics. And for what you can see here, anything 2D, it just has like 2D at the back of it. So a rigid body is for 3D, and a rigid body 2D is for 3D. So let's go back to our Unity and see what that looks like. So just share my whole screen and go back to Unity. And yeah, so let's just go and sorry, this is blocking here. So you go to add components here, and in the add component we have physics 2D and physics. So this is very, very important. If you apply 2D physics to a 3D game, it just wouldn't work because of like the z-axis. So that one z-axis has a lot of complexity that each of them has to be separated. So you have your 2D physics, and you have like the things you can do in your 2D physics. So you have your Rigidbody 2D here. So you can add that down, which we would definitely play around today with. Do that one again. We also have your colliders. So your colliders too are very, very different from your. So let's just have a quick project and let's test that out quickly. So create a new project, call it 2D scene, a quick scene, sorry. That's just save it. So in our game view, take the camera and let's set this to orthographic. So that's straight. So this is our 2D scene right here. So let's just add a, okay, that's interesting. Okay, I can't add it to this thing here. I will have to create a new project. 1 minute. So one thing that come here. So let me create a new project. So come to your Unity hub, new projects. So come new project you want to do, you want to make a 2D game. So go here to 2D and press, call it ECX 2D project. Right? So basically, what you guys did for the spaceship shooter is what we want. No, not necessarily what we want to recreate, but what we would love to do. Let's give it a bit of time to load. This will be done. One minute to soon be done. Should I open it area? You guys see my screen?
Yes, we can.
Okay, cool. All right. So let's add a new. So go right click on the hierarchy to the image, add a new square. So we have our square image right here. Let's focus on that bad boy. So let's create a floor. So basically, this will be this square will add as our floor. So just stretch it out and break it down into it. So we can change the color here. So in the sprite render, I can change the color here to something darkish, I guess. Yeah, let's go black, right? Let's go black. Background image, let's make it tinted blue. It's sort of tinted blue. So we have our floor. Let me make it brown actually. Yeah, okay, that's better. So we have our floor. So this is meant to be our ground, and we just have our player character. Let's make our player character currently a capsule. Okay, the player. Let's add it here, right? So for basically what we learned, let's give it red. Oh no, I like red. Blue. Oh, this looks bad. Yeah, let's give it red. Okay, cool. So this is our player character. And the first thing we want it to do is we want to add physics to this guy. So let him fall down here, right? If I'm not wrong. Yes. So I want it to fall down straight down here. If you guys can't get what I'm doing, just let me know. So I want this guy to fall down and land on this game. So from what we have learned, the first thing we want to add gravity is what? Can someone answer me? So let's make this interactive. So the first thing I will add is what to the component. Anyone? Okay, we added a Rigidbody, but this is 2D. So what would I type down? A Rigidbody 2D. So not just adding Rigidbody, adding a Rigidbody 2D. So add Rigidbody 2D. it should work. So click on play. Immediately it falls. So one thing you notice, like, it falls straight through the ground, and you should follow it. You can see it just keeps falling, so it's untimely, like for like to infinity, right? So your camera can't correctly see it. Let's go back to it. So what do I add to it to make it collide? So to make it collide, we add a collider. So let's add a collider to the player. So what kind of collider will I add here? So the type of collider you add really matters. So let's go to our physics collider here, and we have what they call a capsule collider. Because this thing is shaped up like a capsule, we're looking for the closest thing. Whereas the closest thing currently is a capsule. You click on the capsule collider, and you can see that it perfectly merges. Perfectly merges. Right? So let's click on play real quick. As you can see, oh, it still falls. And basically the reason why it still falls is because the floor itself is not registered as a collider. So the floor itself doesn't have a collider. That's why it falls. So you need two collisions to make a collision. Two colliders to make a collision. So let's add this here. So let's add what kind of collider will I add here to the floor? So for the floor, I'll go to add components, physics 2D. And I will say, oh, you know what, a box collider would be nice. Adding a box collider would be the best that fits up the whole floor. So add that there. So you can see it perfectly fits up. So if you want to probably edit it, just come here. You could probably edit it and make it like smaller and so like that. So those are ways you can add. So let's click play on this and let's see what happens. Oh, and it stands, so it perfectly collides with it, right? So I do like this, but like it's a little bit boring. So let's add some spheres on top, right? So let's go to add components to the image, to the sprites, and add a circle. Oh, not sphere, sorry, circle. So the circle, we have a circle up here, and add the components. Oh, this is stopping. First of all, the collider to this. So you have a circle collider, and the next one to add is okay. So add the same collider. I want to add a Rigidbody to the body. Let's now make this many. So let's just duplicate this. This is in action. Okay, so we have many balls and many circles here. Just click on play and let's see what happens. So you can see it perfectly collides, right? We also have so they're falling down and it falls down. So this is very interesting looking, very interesting looking physics AI, right? So one thing is that the player rotated and fell down, and there are things you can do to everybody to like restrict the movement of some different parts. So if I don't want this guy to, let's say, rotate and fall down, I'll go to my constraints and I'll constrain and I'll freeze the rotation. So freezing the rotation of the player. And once I press play on this bad boy, you get to see what happens. So it still does all the basic interaction, but you see it's not flipping or it's not rotating and falling on the shoulder compared to when I did this. Right? So you can see it's definitely fall down. It's definitely fall down and it falls. So yeah, those are ways you can freeze the different. So there are also really cool things you can also do. So you can decide that each of these circles has a lower gravity. So the gravity applied to these ones are probably like 0.3 compared to 1. So changing the gravity scale, so you get to see what happens. So it doesn't fall out quickly. It still falls out, doesn't fall out quickly. And you can also decide to like make the gravity -1, and you can see it goes up, make it 1 back. I can see it should fall down any moment now, and it falls down. And you can make it, let's say, -0.1. And you can see it goes up slowly, right? So we can mess around the gravity as much as we like in 2D. I think 2D has more control over how the physics play than 3D. So that's one really cool thing you can also do. The next one is so let's go back to our documentation and let's see what we do here. So we talk about 2D and 3D, how 2D is different from 3D is physics, and you must keep that in mind when you're working with it. The next thing to do is Rigidbody scripting. So this Rigidbody we're playing around with, like, let's mess around with it, right? And we have a very basic script here for us to kind of like manipulate the physics objects, right? So we'll go through it step by step, and I will take you along the way, right? So let's concentrate on this one. So I'm just going to disable all these bad boys, right? I'm going to do a player controller, and just going to go down here. Add a new component, right? New scripts, movement. Create a new script called movement, and let's just create an add. So as I'm scripting, once you get lost, please try to pull me back. Don't be scared. Don't be shy. Everybody here is a very loving foundation here in total actually. So open up Visual Studio, or you can use Visual Studio Code, or you're using Notepad. It depends on what. It doesn't really matter what IDE you're using. IDE as in integrated development environment. Okay, so yeah.
I didn't see how you created that script.
Oh, okay. So I basically use a shortcut, right? So to create, there are many ways of creating a script. You can create a script by right-clicking in the project view, create a new C# script. So that's one way of doing it. What I did was like, 1 minute. So once I click on add components here, I can just write down the name of the script I want it. So if I want the script to be player controller, so I can just click on new scripts, and to create a new script for me called player controller. So that's the shortcut, and that's a quick way to add whatever you are. So add the new scripts. So you can also, another way of doing this is in the component section, you could go to new scripts. That is way down here. So when you click on add components, you go to new scripts here, and then you actually name your script. And my script is called jump boy, and I can click create and add. So that's the shortcut of creating scripts. Do you understand?
Yeah, thank you.
All right, awesome. Okay, so let's go to our script. So first of all, we talk about variables, right? And what are your variables? Your variables are what store your data, right? So the first data I want to store is the speed of our character. The speed of our character. So we want to make it public. So public float speed, right? So what is public? Please, actually, let's go through this slowly. So what is public? Why am I writing public there? Does anybody know why I'm writing public? Anyone? No one? No one? All right, cool. So public is so that I can change the variables in Unity, right? Is to expose the variable. So our variable is a float variable called what? called speed. So I want to be able to change the speed in Unity without even having to come here. So let's just see what that looks like in Unity. So come here, load 1 minute. And I click on the player, and you can see it now has a new variable here called speed. And I can write 2, I can write 6, I can usually change what the speed is, right? And I can also, if I make this private, if I did private, sorry, I wrote like 7 or like 1, or I just leave it like this, right? And I go back to my script, right? I can't see anything again. So I can't modify the speed unless I modify it inside here. So for us to modify it in Unity, we go to public. We just write public there, right? So another thing we need to do again is once to create a public Rigidbody today. Call it RB. So we're making a reference. We are referencing. Oh, sorry. We are referencing the Rigidbody components. Oh, sorry, components. So we can control it. So once we control the Rigidbody components, and we can influence, not we control, actually influence it. So more of influence, less on control. It's still the same thing. So we can influence it, right? So we need to tell the scripts that we are looking for a Rigidbody component and we want to be able to influence it. So we can come here. Now, game object right here, and you will see something. It will ask you for a Rigidbody component right here. So I'm looking for this. So we have the speed. You can set up the speed to 5, or let's say 5 right now. And the Rigidbody component right now is set to what? Is set to 2. It's set to none, right? So I can decide to close this, drag my Rigidbody component and add to here. So that means it's telling me that I'm using player's Rigidbody component. That's the component I am referencing, right? There are many other ways to do it. There are many ways to reference it, but this is like the easiest and straightforward way to reference it. So the first thing we want to go to is our update method, and I believe he talked to you about what update method is, right? Update method is every frame after the first frame, right? It's called once per frame, and in every frame, what you want to write down? We want to be able to move our player left or right, right? So once you get down the arrow keys, so what we do here, we create a float here, so float x. So call it float float x, or let's call it float left or right. Left or right. And we'll set it to inputs. So we want to get the inputs, just get access. So we're telling Unity we need your inputs, and what input do we want? We want to get axis. And what axis? We want to get the axis of the horizontal keys, right? Horizontal. So basically, we say input does float is equals to input dot get axis horizontal, right? So we are telling Unity that we need the left or right keys or the horizontal keys of the of Unity. I want to control our character left or right. So we are storing that value to the floats left or right. Now let's explain what that means, right? So if I do debug.log left or right. So debug.log means I'm printing this out left or right, right? So let's just check that out. So I'll open my console window, 1 minute. And I'll show you what that means. So click on play. So look at my console window, everyone. So my console window currently is saying 0, right? So it's telling me 0. And what does 0 mean? 0 means like I'm not pressing anything, right? If I press right, you can see it's now showing 1. So look at the console window. It's now showing 1. And if I press left, you can see it's now showing -1. So remember the first time, once we want to move the objects either to the negative or the positive, this is one way you can get that, right? I think that's understandable. I believe so. So why now I think we understand why we are storing the value in a float, right? So we're storing the value in a float. So the next thing for us to do is I want to be able to manipulate Rigidbody component. So to manipulate is to write down the reference. What's the reference? RB. RB dot what? Dot velocity. So the velocity is really here. The linear velocity of the Rigidbody in units per second. So I want to change or manipulate the velocity of our object, right? So our velocity is equals to new vector 2, right? And the velocity will be equals to left or right times speed, or left or right, so be no, let's put 0, right? Comma times speed times time dot delta time. Straightforward, right? So yeah, actually I've used this. This is way more easier actually. Let me just use this. So basically, I want to tell the computer that hey, we want you to set the velocity based on what we are currently pressing. So if we are pressing the left key, once we want to move, we want to set the velocity, or how velocity basically is how fast is a vector. So how fast is the object moving and in what direction. So once say okay, we are moving at this particular speed, but only on the x-axis, and that's why like the vector 2 here is set to so the x-axis is set to left or right, and this is set to what? It is set to 0. Or I can just write RB the velocity of y and just put it out there. Okay, so let's test this out quickly. So click on play. And I press my right. So you can see I can move it left or right. I can see it rotated and fell on its own, and mainly because like I didn't freeze the rotation of this z-axis, but we can see it doing what we want it to do. I'm gonna just reduce this actually. So freeze rotation, increase the speed to let's say 9. That sounds like a good speed. And let's now test that out. So drops, goes forward, goes backward. Beautiful. So it does what we need to do. So it's moving forward, backward, right? So let's now play around with the circles. So I'm just going to take the circles, enable them, that have physics applied to them. What's their mass in? Their mass is currently, let's do something small like 0.3. Gravity scale of let's say 0.5, half the gravity. And let's play around with it. So now that I can move it, I can now do this. I can move it around. So I just cleared the whole screen of the balls, right? So let's add walls. Let's just add walls so we can play around the balls in those walls. So press plus sign, create a new square. Take this. This is a square right here. On it, just take all the circles up, move them just a tiny little bit. Alright, so take a square. Let's just increase the scale, up, down. And let's duplicate this and come here. All right, so move it here. Let's make it black, right? So we have two bounding boxes, two very beautiful bounding boxes, right? All right, let's go. Okay, cool. So, but then I didn't add my box, so I add my box colliders, box collider 2D, so we can have collision enabled. So click on play, and I can play around with my with them. I can play around with it in the scene. So play around with them. Oh, cool. So I can start them around, play with them around, and you can see how beautiful and joyous they are moving, right? And the force, they're even applying much force to me actually. So that's a very nice way of moving your character around, right? So let me test something out. Let me set them to a gravity scale of 0.2 and a mass of 0.1. Also, I want to add a bouncy physics, so create a new physics material. So physics material is basically how you want the physics to interact with the world, right? So, create 2D, a physics material 2D, right? So I want to create a new physics material 2D. So let's call this bouncy. So we want our balls to be bouncy, right? And we set the bounciness to, let's say, 1. I'll set the friction to 0.1. So you can mess around with these values and get what you want. But I want my balls to be bouncy. I'll just drag and drop them into the material, right? I'm just going to press play. If you feel I'm moving too fast, please call me back. All right, so we're just going to press play, and you can see our balls are bouncy. Yay, bouncy balls. Right, so our balls are bouncy. Don't let the ball touch the ground. Okay, cool. So we have a mini game here already, actually. So let's just bring this down a little bit. And let's duplicate this floor and put it up. Let's make this circle. I think the bounciness is probably a little bit too much. Let's make this 0.4. Maybe 0.4, right? So click on play, and we can have a right. So our bouncy balls are basically, they are less bouncy now, but we can play around with them, right? So what that cool thing I love my character to do is teach it how to jump. So I love my character to jump so I can like play with these balls a little bit more, right? You can see I'm really having fun here playing these characters. Just having fun, enjoying myself playing with these characters. Okay, so I'm having too much fun. So let's make our character jump. So let's go back to our script here, and let's teach it how to jump. Right. So the first thing you want to do is you want to be able to change how high it jumps. Right. So let's go back to our script. Let's add a new variable here, and because it's public float, and the variable we want to change is what variable? Variable we want to change is want to create a new variable called jump force. So how much force is being applied. So to do that, I want to check even when we press the space button. I want to check if space is being pressed, right? So if inputs dot key gets key down, so once the key is being pressed down, I want to get what key code dot space. So whenever the space key is being pressed down, I want to jump. So how do you jump now? There are many ways you can do it, but the best and viable way to do it is using the best and viable way to do it is using Rigidbody dot add force. I want to add a force to it. Ori, you're welcome. Can you hear me?
Yes, I can. Thank you. Good evening.
Good evening. Okay, so we want to add force to the Rigidbody components, right? So we want to add a force to the components and want to add a force up, right? So create a new vector 3. Want to add it up, and up is what on the y-axis. So we add a new force up and multiply it by the jump force, right? And that is how you make it jump. So making it jump is usually want to add just a small force to the I want to add the force to the character whenever you press down. So that is basically the 2 lines of code here, which is we get the input, and if we are pressing the space button down, we want to add the force up, right? And up is usually the y-axis, right? So this is, and y-axis is denoted as what? As 0, 1. So I guess everybody understand the concept of vectors. Does everybody understand what vectors are? I want to be able to understand what vectors are. So let me just do a quick crash course on vectors. Notes. No. 1 minute. Can't find. No. No worries. It's fine. It's fine. I'm thinking of. There's no notepad here. Okay. That's fine. Okay. So let's check if our script is working, and then I'll give you guys a crash course on how vectors are and how they work. So let's go back to our player character. Scroll down here. We have the speed and we have the jump force, right? So what is the jump force? The jump force is basically the jump force is how high it jumps, right? So let's set that to 5 and let's test that out. So just
Hi, is anyone here? Hello, can you guys hear me? Okay.
okay. I'm back. All right, cool. Sorry, I had a quick internet issue. All right, so yeah, what was I talking about again before I left? We could talk about jumping, right? So when I click on the space bar, yeah, no force is being applied to this bad boy. So nothing's happened. So once I put 10, let's see what happens. Still nothing. So 10 is probably not powerful enough to make it jump. So let's make this 50. You can see it's it's definitely jumping, but really small. And let's set this to 100. Let's multiply it. And it's jumping really small. So let's ramp this up to 5,000. That'll be really powerful. Oh god, that was very powerful. Let's set this to let's reduce it, put it to 2,000. Powerful, very powerful. Set this to 100, 1,000. Still really powerful. Set this to 500. Okay, I guess this will be the best one. All right, we have it. So it's moving fine. So 500 is our distance. It's a very good jump height. A very good jump height. So that's how much force is being applied. So we can jump up, we can play with the balls, and we can enjoy ourselves while playing with the ball. So this, you can have like a mini pong here actually. So this is a very nice way to work out with physics, and I think you can jump infinitely actually. So yeah, a very nice way to add jump to your game, at the same time learn about physics and how game are how objects interact with each other. Does everybody understand these parts? Does everybody think this is cool? This was just play with these balls for a minute. So yeah. So any questions before we go? There's like 3. We'll move on to the next. Any questions?
Sorry, please, can we go back to the code? Can you please run through it?
Okay, yeah, I would. Yeah, okay, I'll do that actually. Okay, cool. So let me quickly do something. I want to give you guys a crash course on this. Okay, 1 minute. So share my screen. All right. So I'm starting a whiteboard for my mirror. Okay. So I want to go to the screen. So the first thing we did was our variables. So the variables we want to control and change. So the first one we did was our speed. Make it a public float speed. So our variable here is float. Then we also want to make a reference to the rigid body, and we call it RB, right? So we call a public rigid body to the called RB, right? Then the next one is our jump force. We wanted to be able to control how high our character is jumping, and we call the public float, call it jump force, right? So just wait for this to load up. And we'll talk about how vectors work in games. So which is very, very important. And so I think if we did physics in why is this not working? It's too laggy. Okay. So the next is our start. So we didn't use our start, so we can just delete this, by the way. So we'll talk about the update method. So you all know what the update method is for. So the update method is every frame in this game or in the simulation. Quick, pretty slow. Then the next one is what are we doing in our update function? So everything we're writing is under the update function. We want it to happen continuously over the period of the game, right? So the first thing we're doing is we're collecting whether we're pressing left or right by using inputs to get axis horizontal. Inputs could get as you want to get if we're pressing up or down, what we use vertical, right? So on our keyboard. Then the next thing is we're changing the velocity of the rigid body, and I'll get to explain that very soon on what that means. Okay, all right, cool. Okay, cool. So one moment. Okay, cool. All right, cool. So welcome. So here is fair, right? My drawing skills is bad, so excuse me. So here is basically a ball, and we want this ball to move in a direction, right, in the world. So the ball is a 2D ball. We can either move it up on the x-axis, or we can move it right on the y-axis. Sorry, that was a mistake. You can move it up on the y, or you can move it left or right on the x-axis, right? So this is my handwriting is bad, so I can't draw with the mouse. So yeah, so when you are dealing with vector or vector maths, one thing you should know is that we have the coordinates. So basically x or y. So going up here, we have your y. Going up here, we have your x, right? So wherever it's being placed, wherever you want your object to move, it's basically you have to draw it on this coordinate axis. So if our ball is in the center right here, right, in the center. So in the center here, our velocity currently on standby would be 0, 0, right? So 0, 0, which means like this is x and this is y. So our ball is on 0 and our ball is on 0 on the x-axis and our ball is on 0 on the y-axis, right? So we want our ball to move in any of these axes, right? So I will have a quick, so the first thing we want us to do is we want it to move in this direction, right? It's directly here. So straight here, up here. So for us to move in this direction, that means we're moving west. Our coordinates will be what? Will be x is equals to 1 and y is equals to 1. Why is that? So here, if I'm moving this way, x is equals to 1 here. If I'm moving this way, x is equals to minus 1. Moving upwards, x is equals to 1. Moving downwards, x is equals to minus 1. Please, can you guys see what I'm writing? Okay, I'll use a sample text instead. Okay, all right, cool. Let me just erase everything here. Oh, this is. Okay, that's a very poor eraser. Okay, I'm coming. Okay, cool. All right, I want to just redraw everything and use this as a. Okay, yeah. So we have this. Okay, cool. So we have a line here, and our line is. Okay, I think I like this one. Cool. Okay. All right, so create a line here. Just create one line here. .1 minute. I thought I get something horizontal. Sorry, I'm gonna call again. Okay, wait. Okay. And let me just do this again. Okay. And just draw an outline here. All right, cool. So we have our y is equals to 1 here. And we have x is equals to 1 here. Sorry. Okay, wait. Sorry. Let me change this blackboard actually. So I have these two lines here, right? So put this here, put this here, right? So we have y equals to 1, and we have x equals to 1, right? Let's scroll down. We have y here is equals to minus 1, and we have x here is equals to minus 1, right? So a ball in the center here, having a ball in the center here, so we have a yellow ball in the center. But this is a yellow ball in the center, right? So our yellow ball in the center currently is on position what? So our yellow ball center is on position 0, 0, right? Where the is called x, y, right? So if we want our ball to move, let's say in this direction, we want our ball to move in this direction. So in this direction, like we mentioned before, this is x equals to 1, x equals to 1. Our ball is now what? our direction is now what? Direction we're going in is what? Is 1, 1, right? So if we want our ball to move in this direction, right? That means our what? Our direction we're moving in is what? Can somebody answer that question? Is 1, what? Minus 1, right? So can somebody help me answer the next one? So if our ball is moving in this direction, what would it be? If we're moving in this direction, what would it be?
-1, minus
Answer
1.
that. All right, -1, -1. Pretty so straightforward. So thank you very much. So -1, -1, right? So this is like our very basic elementary of how vector marks work in how vectors work, right? So when are we going with our velocity? We want to tell the ball we only want to move in this direction, right? So we only want to move in this direction. So direction wants to only move in. We only want our ball's velocity move in x, 0. So go to the left. So this is we call this the left, right? Or 1, 0, which is the what? Right. Okay. All right. So yeah. So we want our ball to look back to our script. We want to say that okay, this is direction we want our ball to move in, either like this, right, or like this, right? So, but then how do we get that? How do we know? How do we know what keyboard we are pressing, right? We use input to get axis horizontal, right? So we store. So the way this works, which I tested out, was that if you press left, it goes to -1. If you press right, it goes to 1, right? So that is the way we deal. That's the way we deal with this, right? So we get either go to -1, go to 1, and we change the velocity of the rigid body to it, right? So the velocity of, so we create a new vector 2. So this is how you create a new vector 2. So the rigid velocity, the velocity is now what? Left or right, right? Times speed. So that means, what does that mean now? So that means like if our speed is, so if speed is 5, right? That means we will going at what? At the velocity of what? At velocity of what? So our velocity would be 5, 0. That means I mean like 5 times fast to the right. Does that make sense? I want to assume that makes sense. We're going 5 times like fast to the right, right? No. Right? Okay, cool. So that is so velocity basically is the direction and the speed at which you are going, right? So our direction here will be 1, 0, but the speed at which we are going will be 5, 0, right? So maybe 5 units fast to the left. And the reason why I did this here was because I want to retain the velocity of the want to retain the velocity of the object. So if I want to press a jump button, right, we shouldn't override the y-axis. We don't want to mess around with the y-axis basically. So that's why we left it there the same way it was, right? So that's the way you work with vector 2. So the next thing in our script here is input.getDown key code. So input.k key down. So if we're pressing space on our keyboard, we want to be able to like do something, right? So we talk about if conditions in week 2. So what you want to add a force. I'm adding a force what to 0, 1, and 0, 1 here. So 0, 1 is here, right? So 0, 1 is like this, right? So 0, 1 straight up. So we're going up. So that's 0, 1. So that's the force one. We want to add the force to it in this way. It's that straightforward, so to multiply that by the jump force. So it's that straightforward. Does anyone understand? Do we have any other questions before we move on to our next module?
Why is it RV velocity dot y? Why not dot x? Like, I don't understand that part.
Okay. All right. Cool. So let me tell you thinking or my thinking behind that. So let's set this to 0, right? Let's just set this to 0, right? Control S and then go here. A minute, and I'll press play. So you can see, like, I set to 0, but it's overriding the physics. So physics is adding, gravity is adding pull to it, and at the same time, the jump is not working as it should because we're always setting it to 0, right? So what we want to do is that, like, we want to tell the computer, like, hey, the velocity, your y direction, right? So that means we have two things, right? So our y is being influenced by two things, right? So y is being influenced. So our y position, our y variable, right, is influenced by gravity, right? So our y variable is influenced by gravity, and if we set velocity equals to 0, gravity doesn't work that well. Doesn't work well, right? So what we want to do is that, like, we want to say that our velocity should be equals to our control, so either our left or right. So left or right, right? Comma, it's the current velocity, the current y on the current y. So basically what I want to do is that, okay, we don't want to influence you. We want to just keep you the same way you are being, the same way you are, without influencing you. So when your gravity still work on you, we don't want to mess around with you. Just leave you the way you are currently. So if, let's say, gravity is adding an upward force to you right now, we don't want to mess with that. When we let gravity do its whole work, because all gravity does is set the y position. If let's say the y position, set it down. That's what gravity does. Is that understandable? You guys understand that? Is that clear?
Yeah, I understand. Thank you.
Okay. So yeah. So all right. So that makes sense, right? So this is very easy. This is straightforward, and we get a very straightforward answer. Okay. Moving on. The next thing I want to talk about is prototyping in games. So I want to make a quick prototype using physics objects, right? So a quick runner prototype using physics objects. I think that's the slide. So that's the last part of today's. I don't think we have much time for it. I think I'll do that an assignment actually. I'll do an assignment actually on how just make a runner game, a 2D or 3D. I think a 2D runner game. With physics objects. So you could use the scripts I used here. So let's do something quirky now, right? So let's disable our walls. Let's just delete our walls, right? Let's quickly do that in the next like 5 minutes. So I want to show you what I can do. So I'll make the camera follow. I want to make the camera follow the player. So add a new script. Call this camera follow. So the camera follow the player. So We tell the camera, okay, where is it still loading? Wait for Unity to finish compiling. Edit. The first variable we want to add here is what do you want us to follow. So create a new transform, call it player. I want to control the player. And our update function, I want to set our this dot transform dot position is equals to player dot transform dot position, right? Not really, actually create an offset. So on to create, so let's quickly see how that looks currently. So I press play, okay, so I need to set the variable. So we have an error. So the error we're having here is that the variable of the player of the camera follow is not assigned. So we're not assigned what the camera should follow. So we say player is currently none. So let's drag this inside. And let's press play. And we can't see anything, right? So let's go to our scene view and we can check out something. So currently it's here. So the camera is currently on the player, but it's too inside, right? So if I disable this, the way we should be is that it's supposed to be like this. The camera has to be like away from the player, not in the player. So what we want to do now is go back to our scripts. I want to create a new public vector. We want to create a private vector 3 or vector 2 actually. No, vector 3, yeah. Called offset. And inside the game, we want to set our player, our offset is equal to the distance between the camera, so this dot transform dot position minus player dot transform dot position. I want to always set the offsets here because offsets. Straight off the bat, it should work fine. Okay. So you can see it's following the camera, right? That's very basic, and I can probably fold to infinity right now. Okay, so that makes sense. So we have our camera moving. So let's set the player close to the ground. 1 minute. Let's drag that down. It's a bit. Yeah, we have our camera follow script. So let's create a new world, right? With a world. 1 minute, please. Quickly check with something. Okay, says enough. Says enough. No. Come in. Let's. Unity to the correct. Okay. All right. Can you guys see my screen? So the first thing I want to do is I want to upgrade the graphics of this bad boy. So set the graphics here to yellow or green. Set the green. Set it to green so we can see where we are going to. I think that's all about it actually. So yeah, okay. So probably make it darker green actually. All right, cool. So let's come to our world and let's create a new world. All right. The first thing to do is let's just mess around with this. So going up, you can go up, down, right? Again, so you want to jump here and want to like jump up here again and here. Let's come here. Let's like come here And let's jump over something here, rotate it. So I'm already building my level already. And you could go and draw out how you want the level to be. Let's see how that looks actually. Okay, so I'm jumping, and oh, I can go down. Okay, I can go down. What I think can I jump up here? It's too high, right? So one thing you know that the camera is kind of funny actually. So it's going to do this for aspects. All right, cool. I can't jump up. It's too high, so I have to reduce, or I can either increase the height of the player or reduce the height of this thing. I think I'll reduce it. Let's reduce it. I'll reduce it and reduce this one also because it might be taller. And just increase the height, just a bit. Increase the jump force a bit. Jump force of 1. All right, let's go. So we have our. It's basically you're just running. There's nothing, nothing much to it. You're just running, right? So yeah, let's come here. Just come. So, yeah, so this is you and your game, right? Okay, so me moving and so I can jump on here. I to jump on here. Oh, I jump on there. Jump on here also. And here. So yeah, simple but effective. Does everybody understand? And I already have like my first mini game. Not the best, but it's a proof of concept. Let's add more physics objects apart from the balls to it. Let me see. We don't let the ball touch the ground. Oh, it went 3. So yeah, interesting proof of concept. There are so many fun things you can do here. So one other cool thing I can do here is I can create I can come here, set this to -90 to be straight, a little bit slim. Right? So duplicate this, come here, set this to 0, change to like orange, right? And place it be straight. And I can add a new 2D object. We have triangle. No, 2D objects. Okay. So I have this one. So just going to just increase it a bit. Let me just pick this. Just going to do this here. Drag this bad boy here. It's going to be centered in the middle. It is really centered. It should be. I'm going to add a rigid body to this to make it add to physics. So come here to add a rigid body 2D. Increase the angular drag. So let's say 0.1. So rotate this way and add a collider. So what kind of collider I'll add here? I'll add a polygon collider to this. So a polygon collider is a collider that can it can match up with anything at all. Okay, cool. So we have a polygon collider, we have our balls, and we have a seesaw. So we have our seesaw right here. Let's just make this a little bit longer. Right? So And oh, sorry, I can't see what's going on with me. Anyway, wait a minute. I can decide to increase the width of this actually. Okay, I like this. Okay, we're almost done. So we have a very basic game here right now. Okay, clean. So this could be a game about like just a red ball dancing. Okay. I see we have a very cool seesaw. Are we able to jump? All right. So that's it. So we have a very basic proof of concept. So a prototype is basically a proof of concept, right? So we can try to make this a full game, right? I can show you what it. So when you add like graphics, I can show you what this can look like. Let me just stop sharing my screen, and oh, this is good. Interesting. What is enough actually? I will show you what this looks like, and we are gone. Okay, I don't have it with me here. All right, okay, that's it. Any questions, Zeno?
Is the code again?
Oh, you still want to see the code?
Yeah.
I'm going to copy and paste it for you in the group chat.
Okay, thank you.
I just sent it to the group chat now. Oh, okay, this is the camera follow code. 1 minute. You're coming down now. All right, that's about it. Okay, that's everything. Anything else? Any other question before I leave?
No, thank you.
Okay, cool. All right, so see you next week. All right, bye everyone. Okay, Zainab, all right, bye. But you can still say end the recording.